Hello, everyone. Welcome to another PyData Riyadh webinar. I'm Sarah Salman from PyData Riyadh team. Working alongside with me, Daniel Dothry, Ruba Marwati, Abdullah Nami, Abdullah Nasfer, and Najla Albaz. Also, I would like to announce the upcoming PyData Global event. It will be from 11 to 15 November. And the ticket will be available in the website. We will share the link with you in the chat, inshallah. Our speaker today is Abdulrahman Alfozan. We're glad to have him back. He will be talking about MLflow Part 2. This session will last for 50 minutes. And the last 10 minutes will be for Q&A. Please feel free to drop your questions in the Q&A section. And I'll pass it to you now, Abdulrahman. Welcome.
Assalamu alaikum, everyone. Yeah, happy to be back again. Looking forward for a productive and informative session, inshallah. So I guess I'm gonna take on sharing my screen. Let me share that. All right. Bismillah. All right, yes, we can see the slides, right?
Yes, we can see it.
Right. All right, good evening, everyone. So yeah, thanks for the introduction. I'm happy to be back again. This time we're gonna continue over a topic that we presented last week. So not last week, back in August, actually, almost 2 months ago. So before we do that, I'm gonna go again through just a few slides from the first presentation for the ones who were not there before. I know this was recorded, but I'm just gonna make a quick run through some of the slides. So this is gonna be about MLflow. MLflow is an open source library for machine learning lifecycle. So let's go through this. Yeah, so a bit about me. My name is Abdulrahman. I'm a systems engineer at Facebook. Been there for almost 3.5 years. My focus has been on distributed systems, applied machine learning, and also the development of Apache Spark. Apache Spark is an open source cluster computing framework that's used widely for data analytics, ETL, training, and a lot more. So this tool is MLflow was been developed by the same developers that developed Apache Spark, namely Databricks. So they feel very close and valuable to me. All right, so let's may jump on this one. So this is the pipeline. This is a slide from our first presentation. Going back again, let's go through this cycle quickly. So the pipelines, a machine learning pipeline starts with data acquisition being the first step. So first you have to have an app. Let's say that like a web app or a mobile app would actually collect data. This data is logged to the data warehouse, where it's then processed. The features extracted, then training pipelines that are started. We have different models. Those models are optimized and tuned for serving. Now, once the models are trained and have performed sufficiently good enough, or have performed sufficiently good enough in testing, then they're used in inference. So these are the 4 stages, basically: data acquisition, feature engineering, training, and inference. So let's go through. Yeah, this is the way I discussed it before, same thing. Just another reminder, that a lot of the surrounding components of machine learning pipelines are often the friction point. So yes, the ML core itself is very small, but to support a system that provides continuous and robust development and production experience for the developers and the users is often challenging. It's often a challenging step. And MLflow is trying to help with simplifying and orchestrating some of these. So we talked about this before, and this is going to be one of the points we're going to discuss today: the standardization and tracking. A lot of developers or data scientists would use notebooks to experiment with the model, which was the same thing what we did last time. Last time, actually, we used Google Collaboratory notebooks to develop our model. This time, we're gonna show how we can go from there to an MLflow project and then use it for inference. So basically, the first being using a standard set for experiments, in which each experiment will be consistent to others, so comparisons will make sense. This also goes with model tuning. So I think we discussed it before in the first presentation. MLflow tracking dealt and helped with the first step. Now model stateless is another challenge. I think we discussed that before. Similar. This is another point we can talk more of and do a demo on today. Taking a model from development. So we're going from, let's say you're experimenting with developing a model in some notebook, Jupyter notebooks, for instance. What are the steps that that someone would take to go from there to a containerized environment that's suitable for serving? So we'll do a demo on this part. All right, so I think we discussed that before. Tracking was the three main components for MLflow tracking, being the one of the most essential and the oldest feature, which helps to track training experiments. So each time a training session is run, a lot of parameters are generated, and MLflow helps track those in a way that makes it easy to compare and reference in the future. So this was the topic of actually our first talk. Today we're going to be talking about the two other ones, projects and models, which go hand in hand with tracking as well. All right, so let's talk about then the first component of today's project or today's presentation, MLflow project. So if you recall from last time, MLflow's first use, or I guess first advantage, was to help ensure a consistent logic for running experiments. And by that meaning, each training session will be attached, will be logged along with the parameters used for that session. So a very common parameter or variable that usually data science will use or use as a variable. Like let's say the case of trees will be like depth or number of iterations, or even the error metric. So there usually can be a lot of experiments, and tracking will help put these in one place, such that comparison is easy. Now let's assume that we're able to find a model. I'm going to show this in the notebook, but projects starts from the point where once you achieved a tuned model, then you would like to package it in a way that makes it possible for others to reproduce your work. So first, let's say you actually run experiments, you do your optimizations, and you achieve, let's say, a highly tuned model. Now, next will be to publish this work so others actually can reproduce it and build on top. So that's this is what MLflow projects brings to the table, is some tools and templates that help define a machine learning model. So yeah, this is again the definition. So one interesting I guess, note here is, even though it sounds like MLflow projects is meant to track any, it's meant to be abstract, such that there is no hard coded or hard links to the model you're using. So this could be a scikit model, could be a PyTorch, TensorFlow, or whatnot, which goes back to the philosophy of MLflow, being abstracted away from the actual underlying model architectures or model frameworks. That being said, MLflow does actually provide a lot of flavors built in to make it easy to integrate with common frameworks, which we're going to see in our demo. So what does it take to define an MLflow project? So there are a few, basically a few files. So you start with a simple file, which is the ML project. This is a static file, which contains the definition. This is the name and the entry point for your program or your app. So basically, first defining these, there are two items to define. There is the environment, and there is and also there is the execution or entry point. So in this case, there's a lot of ways to define an environment. MLflow initially supported and still supports Conda, which is a Python virtual environment library. So it allows you to define the set of libraries being used in your project, and then list them in a file such that they can be reproduced. Also, Docker containers or containers is another one, which is what our demo is based on. We can look at these all parameters for our demo. So this is an example. So basically, it's a few files you define. One being the definition ML projects, defining the overall project name entry point. There's also the environment file, the conda YAML, or the container file. There's also the Python scripts included. Usually, it could be just one file to actually trigger the training session. And we're going to look at this in our demo. So now that we described this project or described this component, let's actually go and take a look at this example here. So let me stop sharing, and I'm just going to show you this demo. Let me share my screen again. I guess we'll take questions. And I was going to ask, maybe if there are questions, I probably will take, we could send in a chat and I will look at it. I'm happy to stop and mention or go through the questions you guys have. Okay. All right, just want to make sure, is this readable for most of you? I'm going to zoom in more just in case. Okay, all right, so going to our demo. So this is the notebook, or most of this notebook is actually very much the same as in our session one, with some changes, and we're going to see these. But the main point here that I want to make is for development, for model development and experimentation, notebooks are the kind of the golden standards, or the kind of the convenient tool to use to develop and test a model and play with data and visualization. So this all is pretty much part of talk one. I'll just go through simply. Here we import our data, we do some data pre-processing, and some visualizations for data. Here is we define our model evaluation metrics. In this case, we use RMSE, root mean square error, which is a good metric to use for regression models. We define some helper functions. These are all from the same original talk.
Abdulrahman, can you zoom a little bit more?
Yeah.
Thank you.
All right. Yeah, thanks. So this notebook is still the same as from our original talk. The differences that I'm gonna show is very subtle, very small differences. Mainly being, let me just go through these. Basically, the difference we add here is model signature. What model signature tells MLflow, it tells MLflow what the input and output to the model is. So when we publish it, people can actually understand the semantics of the model. But I will show this in the UI. So this is all the same from, pretty much this whole notebook is from similar from our first talk. Let me go to the new changes then. Yeah. And also there's, remember, this MLflow UI. So we'll just take a quick look at this one. So MLflow UI is also provided by, this is the tracking UI. This is provided by MLflow itself as a way to make visualizations and comparisons easy. We have looked at this also in our first talk, so nothing is too different from then. The only small difference here I'll show you is there are 3 files. So under artifacts, for each training session or each training iteration, which takes in a fixed hyperparameters, like in this case, we have learning rate and we have depth, which are we varying across different iterations. We're tracking these metrics, the root mean error square, and also another continuous validation. But the interesting part here is artifact. So there's a model file, which actually contains, okay, well, okay, so there's a model file. There is the environment variable, which we will gonna be using next in our ML project initialization, and also as well as some other visualizations. So let me go and show you what, so far we have looked at this notebook. Now let me show you what, this is the same project or the same logic, the same notebook, but in an MLflow project format. So MLflow project, basically it's a way to structure and define a machine learning model for that is reproducible. So first we define ML project file, which defines what our project's name is and the environment and so on. So it's very simple. In this case, this is how we name our ML project. There is a Docker environment. So in this case, we're using a Docker container to define our training environment, as opposed to using a notebook. And here we're defining an entry point, how to actually trigger training, simply calling the script. So this is basically the simplest way to define an MLflow project. Just give it a name and an environment and then entry point. So this is the first component of an ML project. The second is we have a Docker file. So this is the environment that we are using for training. For training of for training in all of our experiments. So we're defining our container from Python image. So we're using a very minimal Python base image. We're running some requirements. When I get to these, the requirements file contains the packages used. But basically, we start with a base image and we install our requirements. And basically that's what these 3 lines do. So it's a very simple container, basically. Now let's look at the third file in our ML project. So here we define the packages that are used for training. So initially we have MLflow. Obviously that's a package we're using to manage or to track our experiments. So we're using this one. We're using pandas, NumPy, plotting libraries. Yeah, basically all these were plotting libraries. So it's a very simple project, but what you can see here is we're defining the libraries we're using by version number. So unlike, so I'm going to go back again just to, yeah. So this is our notebook again. As you can tell here, well, basically we're assuming these packages do exist in our environment. We might not be aware what the version is. I mean, it might change every week or so as the platform changes. But the main distinction here that I'm going to make, that when you use a pre-existing environment, that environment could change over time. So this notebook, maybe I imagine, could be at some point might fail to run because of some dependency. Some of the libraries have changed, or some of them depend on something else that's no longer available. When you say import MLflow, you're importing the existing or installed MLflow. But in this case, we're actually defining the exact versions or libraries we're using. So it might look similar, but there's a big distinction here. Like for instance, for scikit-learn, we're using this particular version, our training. What this means, every time I run my container, I'm guaranteed to get the same results, and we'll go through that next. All right, so now that we look at the Docker file, the requirements, I also added the data file. So this CSV file is the file that I fetched and in the step here. So in our notebook, for instance, I'm actually downloading the data file every time the notebook runs. So it's possible this endpoint could become unavailable at one point. Maybe the file can be moved, could be deleted. Any of these issues can happen. So what I would like for my ML project to have is to contain every dependency it has in the repository. So this repository has the data file as well. So I'm no longer depending on some files in the cloud that I could download or not, depending on whether they're available or not. So basically, this is our CSV file. There is a README file, but that's not important. Just for just instructions. Now the last file we have in our ML project here is train. Train is basically has the same logic. We're going to throw this file again. Has the same logic for training from this notebook. Basically, I copied the cells, or the counts of the cells that actually matter for training, which is about half of them. Copy them here. So let's go through this file simply. Again, so we're importing libraries here, and these libraries are imported at runtime, but we are before we import them, as you remember, in the requirements file, or installing each of these. So I can be certain that these libraries will always work together because I already was able to successfully run them. So I'm always going to use the same version of all these libraries. Even if there's a new update in the future, I'm still going to be using the version I hard-coded in my requirements file. So it's always consistent. All right, so these methods, the helper methods, are also from the notebook. Nothing is different. Pretty much all these are copied from the notebook, as is. The only difference here and there is we do not have we have just one file as opposed to a collection of cells. This is all from the notebook. It's just copy paste of the whole thing. Yeah, and this is the end. So here's a training loop, same as the notebook too, nothing is different. So that's a training file. Basically, if this file is called, if you actually run it in Python, it will do it will go through training. So let's do that then. Okay, so I guess we have this project now. Now imagine I could share this repository with anyone, and they will be able to reproduce my exact experiment. I know some of you might say, well, you could also share this notebook. I mean, I could go here and click on share, and I can give a link to anyone, and they should be able to run the notebook. The answer is yes. I mean, that's possible. But the difference here is this notebook depends on external dependencies. It depends on Google's collaboratory environment, which you cannot, which you don't really control control much. They include as much libraries as they would like. They could change. They actually do change every every month or so, as new libraries are added. So it's possible that someone could try to run this this notebook and it might fail because of some conflict or so. But in here we're starting from very defined requirements. So this should always run. Let me show you what training looks like here. So I'm going to show you what would someone do when they actually receive this file. I mean, this is the wiki they have. So yeah, let's go back to our demo. I'm gonna, don't worry about this too much. I will explain it. I guess is it okay? So this is my laptop's. Okay. All right. So this is on my laptop. Let's say this is me or someone else. Basically, what I have in this folder. I have the same repository. I ran git clone and I cloned that repository on my laptop. And I have the same files here that I guess you guys see that's very clear. We have the same files here as we have in the repository. So I just cloned this repo. The next thing is, after I actually cloned it, I will run MLflow run. So this is the new command we're using here. So MLflow run, what it will do, it will actually it will trigger the training Python file, and it basically will generate all the 8 experiments or 9 experiments and log the data the same way as we had in the Collab notebook. But the difference here is that we are running all of this in our in a container, in a Docker container on my laptop. And this could be running on the cloud, could be on EC2, could be on AWS, Fargate, or Beanswalk, or SageMaker. A lot of services we actually can give this container to, and they will be happily running. But I just ran this container or this MLflow project. I just ran it to my laptop. And the command that, yes, the syntax for these is simple. So MLflow run. I'm telling it to use local. I mean, there are options to use the remote, running it on AWS, for instance, which could be efficient if you want to use GPUs or not. And also then I'm using the experiment name. Same experiment name as in the notebook. Here we also get the same data we actually have from the notebook. So the data we read here, or the logs, are also similar. So let's go and let's go and look at the MLflow UI for this session that I ran on my laptop then. Okay, so if you can see here, that's probably clear, yeah. So this is the MLflow UI from the session I ran on, from the project I ran on my laptop. And we get the same experiments that I ran on on my notebook, but they are running here in the container. And also I can inspect them. I can open this one. I can get the notes, all the values that I have logged. Same thing, I get the artifacts too that I have saved. So I have visualizations. There's a feature importance, for instance. We have the model. Here is the model definition. So as you can see, it says the model was trained using Python 3.7 which is what we designed, what we used. We did use the Python 3.7 Docker image, so that matches. Also, we have sklearn's version. What is that? 22.2. And if you remember, if you go to my requirements file here, you could see this is, I'm actually telling my ML project to use the exact version because I know it works well. MLflow actually was honored and did use that version, so you can see it here. There's also something new, the signature. So for each model, I have a list of inputs that tells me, and this will be relevant to our next point, which is the MLflow models, how to actually serve or containerize these models for production. But basically here we have some data about inputs and outputs of this model. So you can see here we have quite a few inputs. If you recall, this model was tries to predict the number of rented bikes based on the day and season and temperature and weather conditions and whatnot. So if you give it all these data, the model will tell you how many bikes are going to be rented. This is useful for a bike rental company, basically. All right, so now that you have looked at this, let me go back to the slides. The same applies for the experiment. Now let's go back to my slides. I'm going to explain the other point about ML models. Maybe actually you can, probably can take, because we'll take questions at the end. Let me share my screen again. All right, so now that we have talked about the ML projects, let's go through the third component. So you could see, well, it logically follows that if you're able to package your machine learning, pipeline in a repository like we just did in my GitHub, how can I go from there to actually serving the model? Which means allowing people to, allowing me or others to send requests remotely to read data. So that's that's kind of the third and the most, maybe the newest component of MLflow, MLflow models. So what MLflow models provides is a standard format for packaging your repository or repackaging your ML project. So you can see each of these components built on before. So ML models, packages, and ML project. And ML project is usually done through ML flow tracking, which is the first component. The point of packaging here is to give a simple interface, like a REST API interface, to allow inference to be executed in the model. I guess demo will make that. We'll also we'll do a demo too as well, which will explain this more. Similarly, for ML models, we define the model signatures in a model, something called ML model file. Similar to ML project file, there's ML model file. Basically, this contains the signature input and output of the model, which we saw in our training. In our training session, in our training script, we actually tell MLflow to log input and output formats. Basically, that's and also we define the dependencies, but that's also could be very much similar to the training. So it makes sense to say, well, the environment I use for training, let's use it for inference too, because it did work and it should work fine. Even though the inference environment can be much simpler, given the model is already trained and there is no need for retrain again, or there's no need for other libraries that are used for training. But for simplicity's sake, we'll just use the same environment. Basically, yeah, that's what MLflow models provides. Just a way to interact with the model that's done in MLflow projects. Now, again, MLflow models is very much abstracted away from the models that are used, and they call them flavors. So we didn't have to package a model that we trained. We could just package any model I got from a colleague or from GitHub or some open source library. The modularity and abstraction of MLflow makes it much easier, makes it really easy and simple to interact with a variety of models. But in this case, we're going to go ahead and use the same model. I'm using the same model and example for throughout all these talks, from tracking, projects, and inference. So let's go through, let's go through this example. Let me share my screen for the model part. All right, let me share the screen. All right, so we're back to the notebook again, but here is going to be a new section that we haven't seen before. So I have a section here that says, let me hide this bit, model serving. What model serving means here is if you have a project like we have here, we can simply with one line or just almost one line create and wrap this model with a RESTful interface that others can use to actually interact with our model. So assuming you have ML projects that's done and trained, you would use another variable, another component, which is called serve. Previously, I've looked at two other variables. We have MLflow tracking and then MLflow run, which was used for the same component, ML project. For MLflow models, we use the serve variable here to indicate that you want to wrap this model. Now, MLflow will need one thing to know here, which is the model itself. Which model do you want to serve? So the model I'm using here is basically the model, the best model I have. So in this notebook, we actually compare the models based on their performance, and I have this variable which contains the artifact or the location of the best model, and we can take a look at this maybe. So basically, here after our training session, I mean, this is familiar. We just saw this in our training window. Here is this is a new part of the notebook, which will all be published, by the way. Here I'm looking at what I'm trying to do here is I'm trying to find the best run, and the best run means would have the lowest root mean square error. So what I'm telling MLflow is search in your runs, which are 8 of them, and order by this metric ascending, meaning the lowest value will be on top, and pick the first one because that will be the best. Now, since MLflow tracking is keeping track of these models and the artifacts, I can simply say, well, okay, the best model, URI meaning the location, will be just basically this variable. And that's it. This will basically will point to the best model itself. Now, this model is a binary file, but MLflow will be able to interact with it. Okay, so I guess we don't need this. So that's what this variable is. And I'm telling it to port, and there is a number of workers. How many workers or how many threads am I going to be using? So 4 is a default. You can vary this as much as you'd like. Now, by this stage, since we run this, MLflow serving is actually running, we can do an experiment, which is calling the curl command. What the curl command will do here is we'll actually make a call to that container. and we'll run the inference. So let's look at this example here. There are a lot of ways to interact with ML models, but this is a simple one, command line curl basically. This is the endpoint I'm using. And I'm using something running locally, so it's localhost. Port is 5001, so these will match. Invocations, it's a way to tell that we're actually looking for inference. There's some headers. Here is the interesting thing here. We have columns. So when I make an inference call, I'm giving MLflow models what the input format looks like. So I don't know if you remember from our signatures, model signatures. Let's see if they're here. Yeah, model signature, there's a list of inputs. So basically, if I'm going to make an inference, I need to match those. I need to provide all the inputs a model needs. And MLflow actually will check for me, and we'll see this in a second. We're going to try to remove some columns, see what happens. But basically, this is the normal case. I'm providing all the variables, season, year, and month. So season 1, in our definition here, one means fall. For year, it's 0, which means 2012. This is the way the way the data is defined, and also and so on. Yeah. So each of these matches, it's a value for each of these columns. So if I click actually run here, I get an inference. So this is the output. What this means to me here, 35, because you know what this model is. 35 means, given these conditions and this time of the day, the model thinks 35 bikes or 36 bikes will be rented that hour. Actually, we can change it. We could say instead of fall, we can use winter, and I click inference, and the value changed. So basically, anyone can send these variables, and let's do something interesting. Let me change. What I'm going to do here, I'm going to remove one of the values. All right, cool, nice. Now I removed one of the inputs. And I get this error message from MLflow models itself. It says model input is missing column season. Well, I guess it knows which column. Yeah, that's good. So it does know that this request is missing or is malformed. So I have to put it back. Let's say season is a number. If I use a string instead of an integer, let's see what this model. So MLflow is able to capture. It said bad request, incompatible input type for column season. It expects it to be an integer. So you can put it back to the number. So yeah, that's a simple demo of MLflow. So this basically, all of these, this endpoint can be called from anywhere remotely. So I could run this command from my laptop. I can give it to a developer. I could use it as a backend for my application. There are a lot of ways to make this call, and I think in models here. So this is the page that we keep, the main documentation page for this model serving. I'm going to show an examples they provide. Okay, so they have actually quite a few. I'm just going to look at one example. Right, so these are the examples. This is also similar examples. The examples we're using look similar to these. So control command. You can also do a batch one. So we could send multiple rows in one call to make it it's more efficient to send to pack as many data points in each call as possible. Another interesting thing you can do is also deploy this model to Azure ML, or there's another service called SageMaker. SageMaker is AWS's, so SageMaker is also AWS's ML environment as a service. So you can deploy the same thing there too, instead of running locally. Currently we're running locally, but I run a container. This container, instead of running locally, could be running on any of the cloud services. The beauty here is with one line, you can do the same thing. Instead of currently we're running locally, we can just say we'll run it on AWS or Azure, and then you can just do the same run the same inference calls. So Yeah, basically this shows our example of serving. Let me go back to our slides because we're almost ready to take questions. All right, let's look at the demo here. Yeah, so this was this was another example. I'm happy to take questions now and explain. So all of this work, all these demos. My GitHub is already has the new ML project, and also the notebook will be published right after this talk, so you can see all these components. But yeah, happy to take questions, and we talk with you. See what you guys think.
Okay, thank you, Abdulrahman. The first question, they're saying, how can we run it on the cloud here?
Yeah, so to run which part in the cloud? So are you saying run the training or run the inference? So ML projects is for training, ML models is for serving. Both are
talking about projects.
Yes, So ML, let me show this example. So I'm gonna show you this example. So how to run in the cloud? Basically, well, the same. Currently in the notebook, I'm using ML run. The only difference is it that it takes. So let's look at Azure. So this is a command I used in my example, pretty much the same, but with a different name, but I'm running it locally. And this is a default example. Now to run it in the cloud, basically, there is instructions to add. So you have to just do some authentication to connect your account. So there's AWS and Azure are both supported. GCP is not, but these two are sufficient. So basically, I will leave it to this guide, which is attached to the notebook. This way, you can go and run it on the cloud by simply changing the endpoint of deployment. Currently, I'm using ML run locally, but this can easily be changed to run in the cloud. Yeah, so the simple answer is MLflow projects does support local and remote being cloud with some extra parameters. I didn't use a cloud here because it will be, it's much more, setup is more involved. I mean, I have it set up for myself, but I wanted these examples to be easily reproducible. So it only takes Google Colab Notebook and the laptop to run all these three components. But all these three tracking projects models can be run on the cloud too, if you go through the effort of setting them up.
Okay, the second question, is there a way to compare the accuracy of multiple experiments from the MLflow UI?
Yes, yeah, it's possible. So I think what you're asking is if we have multiple experiments here instead of one, it's possible to have multiple experiments and comparing them across each other. Yeah, that's possible. I think I can show in the code here. I will show the exact point. All right, so here is I'm looking at the best model. So let's say in this example, I want to look at the best model from across all experiments, not just one. So in here in our case, I'm looking at the best run, or the best experiment, the best run in my current experiment. So the current experiment has 8 runs, and I'm looking at the best one. But imagine there are 3 other experiments too. So basically, what we need to do, which is just give the list of experiment IDs. So currently I'm using just one, but simply MLflow will allow you to because you can see the description, list of IDs. Currently it uses the current experiment, which is only one, but yeah, it's possible by doing something like this. So we can have a list of IDs. Let's say this is experiment number 1. So you can have 2, 3, and 4. And the MLflow will pick the best, will compare all the runs from all these experiments. So yeah, possible, very simply. Yeah, very simply through this, simple by using the experiment IDs parameter.
Okay. The other question, do we have to use MLflow models together, or can we use only the tracking module? Sorry, module.
So I think the question, yeah. So you're asking if you do you have to use the MLflow
All
model?
the
Oh, as in you don't have to use all of them. No, one, I guess one design principle behind MLflow is modularity. So each of these three components is actually independent and can be used separately. So tracking can be used on its own, so is projects, and so is models. Um, there is no if they're used together. If you're using MLflow in all of its components, things will integration will be easy and simple. But definitely not, it's not a requirement, and you could make them work without it. Um, I mean, yeah, the models component basically takes in a model. So if you can provide the model from, let's say you have a Python file which actually loads some PyTorch model or TensorFlow model, and you can define the inputs and outputs, then MLflow models can help you right there. You don't have to train. You don't have to train that model. You just load it from or through MLflow projects or tracking. No need. So yeah, there's a built-in modularity and abstraction between MLflow components, such that any combination of them can be used, if it's all of them or just one.
Okay. The last question: what about computer vision problems?
Well, that is well, computer vision models are orthogonal. I mean, the same. Um, there is no um, inherent difference between what we did in our model here. Um, we're using a non-deep model. It was a boosted 3 model in this case, but that simply can be replaced by a TensorFlow or PyTorch vision model, and training on pictures instead of CSV files. So yeah.
But
MLflow,
in the input data
oh
as input.
yeah, as an input. So good question. So as an input for pictures, um, you would be using so this data payload will be, there are two ways to it. So you can either use a URL, so you can give the URL of the picture, and the model will download the picture and do the inference on it. Or you can use base64 encoding, which means packaging the picture, which means converting the format of the picture to a base64 encoding and making it part of, I'm putting it as part of the payload. So it is, I think I can show an example of this, maybe even this. So this is an example of a different model. I'm going to share it here. Oh, I guess we cannot make it one line. Let me make it multiple lines. Okay, so for like this call here, this call command is calling with some endpoint, a different one than the one I'm using. But if you notice, there is something called data binary. So data binary indicates I'm not using numerical or string data in my payload. Instead, if I'm using an image encoded using base64. So this request is sending this picture, which is encoded here, to the model. That's how. That's kind of maybe the common or a popular approach, a popular way to do inference on pictures. Yeah, so it is still the same call, but data is encoded differently. It's a question of encoding.
Yeah, clear. Thank you. Okay, I guess this is the questions for today. Thank you so much, Abdulrahman.
Yeah, well, it's my pleasure. I hope you guys will found this useful. I'm going to publish this notebook today publish and share the link in our meeting group and Twitter. The ML project is already in my GitHub. I'll also link it again. If for any other follow-up questions, I'm happy to try to answer them. You can write in the meetup group or message me on Twitter or just reply to the tweet. I will do my best. But yeah, thanks for you guys for attending. I hope you found this useful. To actually to learn the most of from these components, I would highly recommend going through the notebooks and the examples to actually reproduce them yourself. Today's session is more hands-on because of it's more production and environment related. So if you found this a bit confusing, I would suggest following the notebook and the GitHub repository. Yeah, and thanks again for listening, and until next time.
We appreciate it, Abdulrahman from PyData Riyadh's side, carving out the time despite your busy schedule. Thank you very much. We appreciate it.
My pleasure.